Hey guys, welcome to my channel, and topic for today is Leetcode number 69, that is square root of x. So let's go with the problem statement first. So we are given a non-negative integer x. So we are given a non-negative integer x, and we want to find out the square root of x. So whatever is the square root of x, that is what we want to find. Okay, so I can say t is equal to under root of x then. Okay, from understanding the problem statement. Then I have to return the same thing rounded down to the nearest integer, and the integer should also be non-negative. Okay, so we cannot return negative values. We cannot use built-in exponent operator or like power or x double times operator in Python. So we are given a non-negative integer x, and we want to find out the square root of x. So I can say under root of x is what we want to find. Okay, so under root of x is what we want to find. I can say it as t is equal to under root of x for now. Okay, so this translates to t equals under root of x. That is what we want to find. X is equal to 4, so I can say t square is equal to x, and t is equal to under root of x, and so the t will be under root of 4, so the t will be 2. Okay, so that is what we returned here in the example number 1. So let's understand another example where x is 8. Okay, so the t square is equal to x, t is equal to under root of x, and we can say t is equal to under root of 8, t is equal to 2 under root 2. The t will be 2 into 1.41 something something, so the t will be 2.82. Okay, and if we take only the integer part of the answer, we are actually expecting 2, so that is the reason why we are having 2 as answer. Okay, so we understood the problem. Now we understood the example. Now let's go to the brute force solution for this code. Okay, so the first thing that came to my mind when thinking of the solution for this problem was, let's think it as a number line. So we have a number line starting from 0 till n, and we have interval of 1 2 3 4 5 and so on till we reach n. Okay, so what we can do is we can go at each point. So suppose x is given as 8. Okay, so we can go at each point and ask its square, is it greater than 8? That is what we're going to ask. If, let's say, for I is equal to 0. Okay, so let's say the I is pointing at, I is pointing at right here. So if I say for the first time, is I times I greater than x? That is what I'm going to ask. So is 0 times 0 greater than 8? The answer is no, it is not. Okay, so if it is not, then I'll just move on to the next index. Okay, so I'll ask again, is I times I greater than x? So what is I? 1 times 1 is greater than 8. The answer is no. I'll move on to the next step. Is I times I greater than x? What is I? 2 times 2 is greater than 8. So the answer is no, since 4 is obviously smaller than 8. Okay, so I'll go to the fourth index. So the fourth index is I times I greater than x. What is I? 3 into 3. Is it greater than x? That is 8. The answer is yes. At this point I will stop. Since, why did I stop? Since 9 is clearly greater than 8, and we are solving for 8. We are not solving for 9, remember. Okay, we are solving for 8. So our answer should be less than this particular index. Okay, so what is less than 3? The answer is 2. So that is what our answer should be. Let's say I is equal to 0. I'm going to set I is equal to 0, and I'm going to do a while loop till I is less than x. Okay, while I is less than x, I'm going to do some action and I'm going to increment I every time. Okay, so I'll just do a simple check. If I times I is greater than x, I'm going to break out of this loop. Okay, I'm going to break out of this loop. And if I break out of this loop, that means I was already, I was somewhere around here. Okay, and I've broken out of this loop. Now I want to return answer, but this can never be our answer. Remember, it has to be one less than it. So I have to return, when I return, I have to return I minus 1 as the answer, not as I. Since if I take I as 3 and x as 8, so it is 3 into 3 is it greater than 8? That is what it will check. Yes, it is, and then it will break out of the loop. But 3 can never be our answer, remember? So we are going to return 2, that is 3 minus 1 as the answer in that scenario. Okay, so let's just go to the coding part of it now. So let's see the code of the brute force. I'll initialize the I as 0. Okay, and I'm going to go from till I is less than x. Okay, if I times I it is greater than x, I'm going to break out of the loop. Okay, and I'm going to simply return I minus 1 as the answer. Let's just run this. Okay, so we are getting output as minus 1, which should not be the case. So let's handle this case. If x is less than 2, we are going to return the same. Okay, so for it will handle for 0 and 1. So the expected answer is 2. The output we are getting is 4. So if I is greater than x, we're going to break, while I is less. Okay, we have to do I plus plus at the end. Okay, so run it. Let's submit it. And I think we will get an overflow error. Yeah, we will get an overflow error since we cannot multiply two large numbers. So let's just store it in long multiplication result and submit it. And it should pass all the test cases for the brute force. Yeah. So let's go to the let's understand the optimal solution now. So let's understand the optimal solution using a number line. So I have a number line 0 to n. Okay, and this number line is separated by 1 units and it only goes till 8. Let's say for now it goes till 8, whatever the x is. Okay, so let's set our x as 8, so the number line goes till x. Okay, so I'm going to say give out the indexes 2 3 4 5 6 and let's just say 7 and then 8. Okay, so now what we can think of is as we can set the starting index of the binary search, and let's just say s is 0 and s is pointing at end, that is 8. Okay, now what we can do is we can calculate the mid. What is mid? Mid is going to be 0 plus 8 by 2 for the first iteration. Then the mid is going to be 4. Once we found out mid, we can simply say, is my mid 4 times 4 greater than target? What is my target? My target is 8. Is it greater than target? Yes, it is. If it is greater than target, that is, if my mid times mid is greater than target. Okay, greater than target. What is my target? My target was x. We will do something. Otherwise, we will do something. Okay, so let's understand this logic. Okay, so let's say we have a line and this represent mid times mid. Okay, when we write this condition, if mid times mid is greater than x, what we're essentially saying is this is going to be our x and mid times mid is greater than x. Okay, in that case mid times mid was clearly greater. In that case we can exclude the right side of this entire thing. Okay, so if we had s pointer right here, e pointer right here, we can exclude the right side of it. If we excluded right side of it, we have to move the e pointer as mid minus 1. Okay, so if mid times mid is greater than x, we have to say e is equal to mid minus 1. Okay, or if you know binary search, it is other way around, that is s is equal to mid plus 1. Okay, so before uh, if x mid times mid is greater than x, then this this right here can never represent our answer. You know, this can never represent whatever you do, it can never be our answer. Okay, but this can be our potential answer. So what we can do is, before saying s is equal to mid plus 1, we are going to capture it in a variable answer. Okay, and this answer can be mid. Okay, so this mid can be our answer. So let's do a dry run on this same thing. Okay, so for iteration 1, we got mid as 4. So 4 times 4 is greater than 8. So let's just do 4 times 4 is greater than 8. Okay, so end pointer will be moved to mid minus 1. So e is going to be mid minus 1. What was e before? E was before 8. Now e is going to be 4. And what was s before? S was 0 before. It is going to stay the same. What was mid before? Mid was calculated as 4. Okay, so let's calculate mid again, and let's discard the values first. So e is going to be placed as here, and the right side will be discarded. The right half of this is going to be discarded. Okay, let's calculate mid again. Mid is equal to s plus e by 2. S is 0, e is 3, by 2 is going to be 1. Okay, so we will do a simple condition check. Is mid times mid greater than x? Mid times mid is greater than x. 1 times 1 is greater than x. X is 8, so it is not greater. 1 times 1 is not greater than 8. In that case, we will go to the else part of this block. Okay, so we will update the answer. So let's say the answer was initialized as 0 initially before the loop. The answer will be updated to mid. What is a mid? Mid is pointing at 1. Okay, so that is what mid was pointing at. So the answer is going to be 1. Okay, potential answer. Okay, so since it is a potential answer, then we will update the starting index. What is the starting index? Mid plus 1. What is mid? Mid is 1. The starting index should move to mid plus 1. So I'm going to exclude the left side of it, left side of mid, and I'm going to say s is equal to mid plus 1. So s points to new index, so it all gets cancelled out, the left side of mid and the mid itself. Okay, so we'll do the mid calculation again now for third time. So the s is going to be 2, e is going to be 3, and divided by 2, this is going to be a mid. Mid is going to be 2. So I'll just quickly reference mid. So this is mid, this is s, and this is e. Again, I'm going to do the same. I'm going to do the condition check. If 2 times 2 is greater than x, the answer is no, it is not. Okay, so in that case, the else part will be executed again. So whatever was the mid, it can be a potential answer. So I'll update the answer as 2. Okay, and I'll set the starting index as mid plus 1. So the starting index will go to the next of mid. So mid s is pointing at 2. So s will point to here. Okay, so let's do the calculation of mid for the last time. So the mid is going to be s plus e by 2. What is s? S is going to be 3. E is going to be 3 by 2 is going to be 3. So the mid is going to be 3. So let's just do the check. If mid times mid is greater than t, if 3 times 3 is greater than 8, the answer is yes. If that is the case, I'll move the end pointer as mid minus 1. Okay, so end s pointer was pointing at 3, end pointer was pointing at 3. So after this, end pointer will point at 2. Okay, now if you see carefully, s and e has overlapped each other. Okay, at that point we will stop the loop, and whatever was in the answer, I'm going to return it as the real answer. Okay, so this was the dry run for x is equal to 8. Okay, Okay, let's just go to the coding part of it now. Okay, and say int s is equal to 0, int e is equal to x. Okay, uh, and then we'll iterate while s is less than equal to e. Okay, we'll do the mid calculation. Int mid is equal to s plus e minus s by 2. Okay, so this is a safe way to calculate mid than doing s plus e by 2. Okay, so refer my second video of this playlist for more. So after this, we will check if mid times mid is greater than target. Okay, if that is the case, if mid times mid is greater than target, we will do something. Okay, mid times mid is greater than target, then I'm going to say is equal to mid minus 1. Else, we can do s is equal to mid plus 1. And this mid could have been a possible answer. So I should store it in some variable. I say answer is equal to mid, and I'll declare the variable answer beforehand. It is equal to 0. Okay, and if I return mid, return answer at this point, we should get the solution. Okay, so let's just run it. So it works. It's accepted. Let's just submit it. But I think mid will again overflow. So let's just do long apply long for the mid calculation and submit it. Okay, so it works and passes all test cases with 100%. It beats 100%. So that's it for the video. If you like it, please subscribe. Thank you. Bye.